Before I get started, I'd like to say that this work that I'm going to talk about was done by a number of people that I've had the fortune to collaborate with, and also supported by a number of organizations, and I'll have more on that at the end of the presentation. So the Hell's Canyon Bighorn Sheep Initiative was started in 1995 after the closure of some domestic sheep allotments, Forest Service domestic sheep allotments. It was initiated by the states of Idaho, Oregon, and Washington, Bureau of Land Management, Forest Service, and what was at that time known as the Foundation for North American Wild Sheep, now known as the Wild Sheep Foundation. And the goal was to more self-sustaining bighorn sheep to suitable habitat in Hell's Canyon. And bighorn sheep are native to Hell's Canyon. Based on archaeological and anecdotal information, they were once very abundant, but were extirpated by the 1930s due to a number of reasons, including diseases transmitted by domestic sheep and unregulated hunting. Reintroduction started in 1971, and sheep have been brought in from Alberta, British Columbia, Montana, Idaho, and Whiskey Mountain, Wyoming. And at the start of the Hell's Canyon Initiative, there were 17 populations within the Hell's Canyon area for a total of 900 sheep within an 8,900 square mile area. And that extended from Lewiston, Idaho to Brownlee Reservoir in the Snake River Canyon, and then also in the Blue Mountains and Wallowa Mountains. Although there were already sheep in Hell's Canyon at the start of the Hell's Canyon Initiative, because of the closure of the allotments and because of the extensive habitat that's available, the founders thought that there was room for a lot more sheep. And so I think the idea was to do more translocations to jumpstart the population. But right when the initiative started, we had a pneumonia outbreak that started in the north part of Hell's Canyon. And it eventually spread to 5 different populations in northern Hell's Canyon. And it was an indication that disease was also going to be an important part of restoring sheep in Hell's Canyon. So right after the outbreak, we wanted to do some things. We knew that often there's extended periods of low lamb survival following pneumonia outbreaks, and that's what we were seeing. So the first thing we did was to do a vaccine experiment where we selected 3 of the populations that had been affected by the outbreak and vaccinated 6 ewes in each population, and captured 6 other ewes and gave them a placebo. And then we also, during the outbreak, we done a lot of work to try to stop the outbreak, including moving sheep to captivity. And those sheep in captivity also were having problems with lamb survival, so we vaccinated them as well. And the results of that were that the vaccinated ewes actually had a little lower lamb survival than the ewes that weren't vaccinated. So the vaccinated ewes are in orange, or if there's nothing, that means no lambs survived. So no lambs survived in this population or in the captive population. Another thing we did was we still, there was still interest in moving more sheep into Hell's Canyon. So outside the area that had been affected by the outbreak, we brought in about 115 sheep from British Columbia, Alberta, and Montana. And we're able to start some new populations and supplement some populations, but not surprisingly, we had problems with disease in those populations as well, sometimes minor and sometimes kind of disastrous. We also tried supplementing the populations with worming blocks and mineral blocks. And we were able, with the worming blocks, we were able to reduce levels of lungworm. And with the selenium, we use selenium mineral blocks with salt, and that's what these sheep are having right in this picture. And we chose three free-ranging populations where we put out mineral blocks, and then three that we didn't. So we had 3 treatments, 3 controls. And in 2 of the treatments, we weren't able, even with the mineral blocks, there was no change in selenium. And in a third, in this population here, where there's some winter feeding and the sheep are concentrated on the winter range and had been accustomed to salt blocks, we were able to increase selenium levels, pretty much double selenium levels. However, we saw no difference in lamb survival in the supplemented versus unsupplemented populations. And finally, we also tried giving antibiotics. This again is this population that gets supplemental feeding on the winter range. And the person in the picture is the district biologist, Vic Coggins, who captured 28 sheep and 28 ewes and 2 rams and administered an antibiotic called Draxxin. And that year, 2 lambs survived. So by looking at the situation, so we had, we're pretty much, it seemed like disease was preventing us from reaching our restoration goals. When we look back now, we have more information, we can see that that the disease was much more extensive than maybe we had originally. That outbreak in 1995 was much more extensive than we had originally thought. So in this slide, this shows the different strains of bacterium called Mycoplasma ovipneumoniae, which I'll refer to as Movi for the rest of the talk, in Hell's Canyon. And the blue strain was the strain that was introduced in 1995. And by 2006, that strain had been detected in 12 of the 17 populations. So it spread throughout the canyon. So if we fast forward from 2006 to about another 5 years, we had done, there was a lot of work done on this bacterium, Movi, both in free-ranging sheep and in captivity. And this basically shows the conceptual model of how we think Movi works in pneumonia, in bighorn sheep pneumonia. So Movi is introduced to bighorn sheep. We don't think that bighorn sheep are adapted to it. It comes from Old World Capriinae, domestic sheep and goats. When it's introduced into bighorn sheep populations, it often causes a pneumonia outbreak. It's polymicrobial, so there's a lot of different bacteria that are detected in this outbreak, and it affects all age classes. And these outbreaks can be highly variable from, very mild, maybe 10 to 20% of the sheep die, to very severe, where 90 or maybe even ultimately the sheep population is extirpated. Following the outbreak, the sheep that do survive, most of them recover and are healthy, but some don't recover, and these become chronic carriers. And the ewes that become chronic carriers transmit the Movi to lambs, which are not protected. And this often causes these annual pneumonia outbreaks in lambs. And so there's low recruitment and the population doesn't recover. In some cases, the population will naturally clear Movi and return to being healthy, and in other instances, it doesn't. So before I move on from this, I don't want to get too deep into the microbiology, but I just want to point out it took quite a while to figure out, to discover Movi, I guess. We did not know about it until 2006. And the reason for this is that Movi is different from all the other bacteria that are involved in pneumonia in bighorn sheep. So this is a slide. I hope you can see this. On these different bars these different color bars represent different bacteria. And on the bottom is a time series from 10 days. These are lambs from 10 days to about 70 days old. And typically in this disease, the lambs die at about 30 days to 1 month to 4 months of age. So when you bring in an animal to the diagnostic lab, which is typically how we find out they have pneumonia, this might be what you would see, which is just a lot of different bacteria. There's some of the known players like Pastorellas, which are in the purple and red, but there's a lot of other bacteria as well. And some are aerobic and culturable by aerobic methods, and others are anaerobic and they wouldn't even show up in an aerobic culture. But if we, so in this project, this was led by, or inspired and I guess led by Tom Besser. And he came out in the field with us and he said, you need to find out what started this outbreak, not what killed the lamb in the end. And so we went out and collected lambs from populations that were having problems with pneumonia. And we started as early as 10 days. Well, actually, we started earlier, but as early as 10 days, we were able to get a profile here. And you see that it looks very different. So in this, these bars, the black is Movi, it's Mycoplasma ovipneumoniae. So at the beginning of the outbreak, it's the pathogen flora is dominated by Movi, but by the end, it hardly shows up at all. And what Movi does is it impairs the immune system and allows all these other bacteria to come in and kill the lambs or adults, so to infect the lungs. And so the Movi, it doesn't go away, but it's just overgrown by other bacteria, so it's not as easily detectable, and it comprises a lot less of the bacterial flora. So that's why we are focused in test and remove on Movi, because so now I'm going to talk about the field studies that we did to try to get rid of Movi. And we worked in 11 populations in Hells Canyon, and we tried to test all of the ewes at least once over 2 years in these populations. And we wanted to remove these persistent carriers. And I haven't really talked about that work that went into determining that there are persistent carriers, but I'm happy to talk about that too if people have questions. We did transfer those carriers to some captive work that we were doing, or some of them just died naturally. We then monitored lamb survival through observation, or in some studies outside Hells Canyon, they radio collared the lambs. And then after we had removed the carriers, we retested the populations. So here again is the study area of Hells Canyon. And at the beginning in 2012, right before we started test and remove, every population except for these two in the bright green on the other each end of the metapopulation was infected with Movi. The Sotan population in the north part of the metapopulation is where we started test and remove. And one reason we did that was because that population had been healthy until 2011, through that whole period. And then in 2011, they had a pneumonia outbreak, and we'd seen how devastating this is to populations. So we had a lot of, I think it might be similar to Whiskey Mountain, where we just decided we had to do something. So we decided to put our all the research that we've done, try to apply that and see if we could make a difference in a Sotan. So in 2013, we started testing, and we removed 2 carriers from a Sotan. And by 2015, Movi have been cleared, and we haven't detected it since. So then we just focused our testing on the north part of Hells Canyon. So we don't really know exactly what was going on in these other populations. We are also working in this Lostine population. And in 2015, we removed 8 sheep from Black Butte because we got a new strain that came into the Hells Canyon population. So we removed some sheep from Black Butte. And then by 2017, Black Butte and the population between Black Butte and Asotin, no Movi was detected, and we haven't detected it since. And then in 2018, that happened with Wanaha, and 2019, Redbird in Idaho. And then by 2020, Movi had been cleared from all of Hell's Canyon in the Snake River Canyon. In the Wallowas, we've so far removed 14 sheep and 14 carriers, and we have not cleared Movi. And unfortunately, during this period, we got a new outbreak down at Lookout in Oregon. So this plot shows the population trend of these both pre and post test and remove. This redbird population was actually started in 1984 by translocation of 14 sheep from Whiskey Mountain. And it's now one of our, it's the biggest sheep in the state of Idaho now come from there. This is the Mountain View and Wanaha population in the Blue Mountains in Oregon and Washington, and then the Asotin population, which was our first population that we worked in. And this shows when Movi was last detected. And so both the Redbird and Mountain View populations have doubled or more, whereas the Asotin population has just has not changed really. I also want to say that in Redbird population, we've noticed that some sheep have actually moved out of the population and colonized new areas of vacant habitat. So our numbers, may be actually higher than this, because we found a lot of these, or several areas, because we have so many collars out from test and remove. But it's pretty cool to see this sort of natural recolonization of areas where we never had bighorn sheep before. Okay, so this is the population level response. Now you remember the demographic that we were focused on was improving lamb survival. And that's what happens after Movi. That's those outbreaks in lambs is what Movi causes. So this is what we were seeing prior to test and remove. About 1 to 4 months, we would have these pneumonia outbreaks in lambs. And this is the survival of lambs born to marked ewes to October, so to about 4 months of age. And this is what it looked like for years in these populations, that we would see somewhere between 0 and 50% survival, with an average of about 15 to 30% survival. So you flip that around, about 85 or about 70 to 85% of the lambs would die within the first 4 months. After test and remove, it was just the opposite, that just about 70 to 85% of the lambs would survive to October. Also, recruitment, although it's a little messier, this looks it's not quite as clear, but it's significantly increased from 0 to 35 lambs per 100, or 0 to 0.35 lambs per ewe, to about 45 to 55 lambs per 100. And this, if you think about the previous slide, showed that's when the peak of pneumonia is. So that's what we were really addressing with test and remove. This shows a lot of other things, including other sources of mortality that maybe are not related to pneumonia. But another thing is that I think this is, whereas the previous slide was based on number of lambs born per ewe to marked ewes, this is just a lamb ewe ratio. And since we had so many lambs surviving, we had more yearling ewes that are too young to have lambs. So also, I think this underestimates what our actual recruitment is. Nonetheless, it's significantly higher, and this is typically high enough for a population to increase. So I feel that we can say that test and remove was successful at stopping those pneumonia epizootics in lambs and in increasing lamb survival and recruitment. even in populations where we haven't seen population response. And I'll talk a little bit more about that in a minute. So what we actually did on the ground, we tested 396 sheep, and we found 21 adults that were positive. And since we were testing 2 years in a row, we would wait a year to retest to see if they actually were a chronic carrier. And during that time period, about half the sheep, after that time period, I should say, about half the sheep that tested positive either died or they cleared MOV. So we only actually removed 9 MOV positive sheep. We did remove some other sheep, as I mentioned, from Black Butte, that regardless of their MOV status, but yeah. So right now, test and remove is being implemented in at least 15 populations in 7 states and provinces, using different approaches. And we're still learning because people are, have different situations and are following different protocols. But the basic protocol is to, first of all, to detect chronic carriers by testing as many of the adult ewes at least once as you can, and then retest any positives the next year so that you can distinguish a chronic carrier from an intermittent carrier. So a chronic carrier will invariably is defined as a sheep that will test positive year after year, whereas an intermittent carrier can clear MOV, although it may get reinfected, but it can't clear. And then to determine whether you've been effective at clearing MOV, we test 6 to 9 month old lambs born after the outbreak or after we've done the removals, and look at both PCR, which probably everybody is familiar with now from COVID, and ELISA, which detects antibody. And those lambs should be negative for infection, and they also should not have any antibodies because they should not have been exposed to MOV. And since lambs are very susceptible to infection, you only have to test a few lambs to determine whether MOV has been cleared. In Hell's Canyon, we're still working on the Lostine and Lookout populations. We're trying to reduce risk of new spillovers, and we have a domestic sheep and goat health program that was featured on the Bighorn Sheep Center webinar program recently, if you're interested in it. But it's really important that we reach out to domestic sheep and goat owners to help so that they can help us keep our Bighorn sheep healthy. We're continuing to monitor health and population trend to see what's going on. We don't know. It's been 6 years since we started, but how long will this last? What will we end up with for sheep? And we're expanding all 3 states, Idaho, Oregon, Washington, are expanding test and remove into other populations. So for takeaways, MOV was supported as a primary driver of pneumonia epizootic in bighorn lambs, and removal of carriers in Hell's Canyon assisted what seems to be a natural process of clearance and attrition. So as I said, some of the carriers just died naturally, and we also had populations that cleared MOV even though we didn't remove any sheep. We also found that a large population, so it can be somewhat intimidating if you have a population of 900 sheep to try to do something like this, but they almost always have some substructure that can be exploited for test and remove. So you can work on these smaller populations. And there's also variability both in how easy it is to do it or how to implement it and the outcomes. For example, MOV is more difficult to clear in some populations than others. And in our case, Lostine has taken a lot longer than anywhere else. And we have, that's something that we would like to look at in more depth. Despite improved lamb survival, not all populations recover rapidly when MOV is cleared. And there could be a number of reasons for this. And this is also something I'd like to look at more carefully. One could be that there's actually something else that's also, once you get rid of one limiting factor, there's another limiting factor, such as predation or nutrition. Another possibility is that there's sort of longer term immunopathology following infection with MOV in some cases. Sort of as an analogy would be long COVID, where even though MOV is not there anymore, those sheep are more susceptible to other pathogens. Yeah, I think those are the two that I can think of that might explain this. And so from here out, another kind of a general direction that I would like to see is how to optimize this technique to minimize the amount of testing and removal that's needed. It's a very intensive action, and if we could, you know, we tested a lot of sheep to remove 9 carriers, and if we could make that more effective and efficient, we could apply this to more populations that are larger and less accessible. And so we'd like to see what is there things on a population level that are associated with or contributing to persistence. So are there hotspots of infection or transmissions, or there's some of those subpopulations that just can't get rid of MOV, but others are. And then, but then since there's connectivity between populations, they keep getting reinfected. So if that was the case, you might only have to clear MOV from part of the population and the rest might clear naturally. And then look for characteristics associated with chronic carriage that could be detected, ideally without handling animals, or at least just in a single test. So I'd like to acknowledge the many individuals and organizations that have worked on this problem over a long period of time. In Hells Canyon, we're in the traditional area of the Nez Perce and Confederated Tribes of the Umatilla, and they are partners on this work, as well as the original founders of the Hells Canyon Initiative, the agencies, and South Dakota and Nevada, who are early adopters to test and remove and have conducted it in the Black Hills of South Dakota and snowstorms in Nevada. The Wild Sheep Foundation, national and chapters, including Idaho, Oregon, Washington, Midwest chapter, and Shikar Safari. Wildlife Restoration, Pittman Robertson funding, federal funding, and universities, including Washington State University, and specifically Tom Besser, who was responsible for identifying MOV as being important in the pneumonia bighorn sheep.
Where's the University of
Wyoming at Montana.
Yes, we haven't done the process yet. We're trying to.
And at Penn State University, the Center for Infectious Disease Dynamics, Kezia Manlove, and finally at the USGS, Dan Walsh and Paul Cross. And thank you all for listening.
Well, that was such a wonderful presentation, extremely relevant, and provided data about the success of this management lever. And thank you so much. I do know that the audience has a few questions. So I will, if those on the line would be interested in raising their hand, I can call on you guys and we can unmute you and we can ask Dr. Francis to share her knowledge with us. I'll ask her to come back into the seat, and I'm just going to relocate to my Zoom so I can look at whose hands are up and we can call on folks from there. That sounds good. All right. The first person with a question is Jesse Neal. Jesse, feel free to unmute yourself and have at it.
Hello, can you hear me?
So I am a student, a veterinary student at Auburn University. So I'm sorry if some of these questions are maybe not the best. But the biggest one that I have is there any research going on into a Mycoplasma ovipneumoniae vaccine or any way to stimulate maternal antibodies for that direction?
There has been some minimal or some limited effort at developing an autogenous vaccine. Mycoplasmas are notoriously difficult to develop vaccines for. And one problem with developing vaccine for Movi is that immunity is strain specific. So it'd have to be some multivalent vaccine, and there are hundreds of strains.
Gotcha, thank you.
Also, another problem, of course, we're mostly would be interested in developing vaccine for domestic sheep, since they're much easier to vaccinate.
Sure, that makes sense.
Thank you, Jesse. Jesse, if I could ask, how did you hear about this webinar today?
So I am taking a disease and wildlife elective for class, and I was actually talking to one of my classmates about my research paper and about my topic that I'm going to present on in a couple of weeks. And she just happened to message me on Facebook and was like, hey, you just talked about this, and I am sure you just wrote your paper, but this webinar is going on this weekend. You should attend it. And so I did.
So is your paper on this topic?
Yes, it is. It's on pneumonia and bighorn sheep.
Well, Jesse, we didn't talk much about it here, but in Du Bois, Wyoming, we once had the largest wintering herd of Rocky Mountain bighorns. So I'll be sure to connect with you after this, just because I'd love to hear more about your paper and your interests, and let you know
absolutely
how pneumonia affected our herd, still is affecting it today. Thanks for joining.
Awesome, thank you.
Francis, the next question we have is from former board of directors, former president of our board of directors, Kathy Trainer. Kathy Trainer served on this board for 7 years, so she has extensive history with the Sheep Center and the Whiskey Mountain herd. She asks if you could please describe the Lostine population habitat geologically. What is their summer weight of ewes versus winter weight? She also says best wishes. Thanks, Kathy.
The geology of the Wallowa Mountains. I'm actually not sure what the geology of Wallowa Mountains is, but I should say that I don't know if you're sort of alluding to the selenium, the availability of minerals in this geology, or because all of Hell's Canyon there's high variability in this part of the country, really overall in availability of trace minerals. And so livestock producers often provide trace mineral blocks to their animals. And so that's kind of where that came from. I don't know if I went on a tangent here, but that's, and as far as the weight of the ewes, we don't weigh them, so I don't know. I do know that some of the biggest rams in Oregon have come from this Lostine population when it was healthy.
Thank you. I think Kathy's point about weights relates to what Steve and I were talking to you about yesterday, about how we're finding difference in winter weights and summer weights from the Pinedale, from the west side versus the
Okay, right. So the Lostine is a migratory herd, and yeah, I don't know. I don't know how their weights compare to some of our non-migratory herds, but our non-migratory herds actually just don't go into the alpine. So they're all low elevation, which I think the opposite is true here in Whiskey Mountain where the non-migratory birds just stay up.
Yeah.
So we have a little different climate, so it works a little differently.
Thank you, Kathy. Next hand up is Pat Mary. Pat is zooming in from Painted Hills, and he's under his wife's alias right now. So, Pat, not Kyle. Hi, Pat.
Hi, I'm curious, you talk about spillover and some of those isolated populations that you had that were healthy at one point became unhealthy. And I notice you concentrate on ewes primarily. What is your experience or your interest in the rams in terms of their potential for spillover between herds?
Yeah, that's a very good question. I kind of skipped over that. And I do think in some cases, rams could be important for not only spillover or, bringing pathogens back to the population, but also for persistent carriage. We didn't remove any rams in Hell's Canyon, the project I just told you about, but in the Lostine, I think our ewes are really healthy, and I think that in some cases rams can become persistent carriers. So that wasn't exactly your question, but in terms of spillover, the rams do move more than the ewes, and particularly young ram. And this, in our experience, young rams or smaller rams tend to do more exploratory movements where they might contact domestic sheep and goats. So I think rams could both contribute to spreading pathogens between populations and also potentially contacting, sources for new spillovers.
Another question would be, what is the normal mortality rate for a healthy population of sheep?
For lambs?
Yes.
Yeah, so I think anywhere in my experience, that early, so that's over summer or like the first 4 month survival, if that's over 50%, the lambs are generally, I think we haven't really seen a lot of pneumonia. Because the reason that the pneumonia is so deadly is that the sheep get together and the lambs get together in the nursery groups. So when one lamb's exposed, then it spreads throughout all the lambs. So you usually have like fairly poor lamb survival, or if they're healthy, I would say 50% or more, or over 50% lamb survival. I would be thinking that population may not have a problem with pneumonia. And in terms of recruitment, I think it can be all over the place because there's other factors that can affect recruitment in different areas.
One of the problems we understand at whiskey is that just due to the heavy and relatively recent glaciation, those that do migrate are on pretty poor habitat in terms of food and nutrition. And I wonder if there's anything that has been experimented with in terms of trying to increase the amount of nutrition in the summer months before they are stressed by the winter. I know that they're trying to do some planting out at Whiskey, and I understand you're doing these mineral blocks, but I understand that the weights are very often low at the Whiskey Mountain herd before they go into winter. And I just wondered if there's any effort to try to make them more robust before they are stressed.
I've done some collected some fecal nitrogen data in the summer, and in our alpine and our higher elevation areas, there's, it seems like it's a fairly crude measure, but they maintain higher levels of nutrition for longer periods than our sheep that don't migrate and stay in the canyon.
Okay, good, interesting. Thank you.
Thanks.
Any questions in the room right now?
The Soden herd, you have a recruitment of around 47 was the value, and why is that herd static when the recruitment is that high?
Yeah, so I have some theories. I mean, I talked about maybe there's like a long COVID. Also, it's a small, just that there's not long COVID. I don't think they have COVID, only deer get COVID. But just that there might be some residual immune issues. We have seen some other things happen that might suggest that there could be something like that. It's also a small population, so even if only a few ewes die, it just could be just not enough to, even though the recruitment's pretty good, there's the ewe survival isn't quite good enough to get it to grow. And we've seen, because we haven't seen any consistent source of mortality, we don't see pneumonia, really, we don't see any pneumonia outbreaks, but you have some sheep that got killed by a cougar, some sheep that had an accident, fell, just a random things, and maybe it's just because it's a small population. I don't know.
One follow-up to that, you mentioned 50% lamb survival after a few months. But can you tell the audience what you need for total recruitment? I mean, all the other issues that would cause the loss of lambs. What's the sort of number that maintains a static population or will build it? What's that magic number? Do we have one or range?
Well, of course, it's not just recruitment. It's your adult survival, particularly ewes. But if you have a fairly high adult survival, typically 90% annual survival, which isn't unreasonable, 85 to 90, then you would need a recruitment of about over 40 lambs per 100 to see the population increase.
And that's a lamb count late in the
That's
winter.
lamb, like right now. So yeah, so if you have 50 lambs per 100 at in October, that doesn't necessarily mean you're going to have an increasing population.
Thank you.
And what we've seen in our increasing, the one red population trend I showed in the Winnaha and Mountain View, that's been 14% a year. So that's would be achievable with test and remove in the right conditions.
One quick follow-up. Can you inform the audience on persistence of these bacterial pathogens in the environment and how's it transmitted? The majority of it.
The particularly Movi, I'll talk about specifically, and most of the aerobic bacteria, but specifically Movi, it's kind of a unique, the mycoplasmas are kind of unique, and Movi is a very vulnerable bacterium actually in the environment. It doesn't have a cell wall, so it will desiccate quickly. It's really directly transmitted, or in some cases, if there's close contact, direct contact isn't necessary, but it has to be fairly close contact in order for it to be transmitted. So that's kind of a good thing, is that it does not persist in the environment.
Thank you. What I love, Dr. Francis, is there's the Sheep Center functions as an education and outreach arm, and there's so many questions still around pneumonia, and having you here today to answer some of these questions is great. It gets us thinking about this in a different light, and asking relevant questions. A question I have is about the definition of a chronic carrier. So in Hell's Canyon, you define a chronic carrier after 2 consecutive tests over a period of 1 year. That sheep would be removed. Can you talk about how you set that threshold?
Yeah, that's a good question. I mentioned this Lostine herd that is fairly tractable. We saw Vic out there walking among them, so they're fairly easy to test, to capture and test. He actually has, you might have seen there was a corral trap that he he has that he's caught them in, and then we also can dart them from the ground with chemical mobilization. So we retested those sheep over and over for 5 years. And then we came up with we calculated what's the probability if you test positive once that you're going to test positive again, and then twice, and so on. And the probability that you'll test positive, like after one time is, it's over 50%, it's like 60% that you're going to test positive again. If you test positive twice, it's about 80%. And if you test positive 3 times, it's 90% or greater. So it was kind of a trade-off between sort of feasibility of number of times you could test animals in other situations where they're harder to capture, and also what we found on the Lostine. So, yeah.
Wonderful. Thank you for that background.
And it has held. We've done a work in captivity. And we have seen that these animals, we've had captive animals, like when we removed our chronic carriers and put them in captivity and we retested them, they did continue to test positive.
Thank you for sharing that note, because during our annual meeting, when we discussed test and remove as a strategy, a question came up from the audience. Is it possible to remove the chronic carriers, take them into captivity, treat them, and then reintroduce them?
I'm not going to say it's not possible, but would be, not all of them. I don't think you'd be able to do that.
Because of the persistence.
Yeah, well, and because we don't have a good treatment in domestic sheep or bighorn sheep. There's not really an antibiotic that works well. And if there was, I would say, no, it's not going to be possible. At least with the current antibiotics that we have, and even anything that might work, it would have to be repeated treatments. It's not just a single shot that you could give animals. So we're really working on that. In fact, Lauren, who is Lauren Christensen, who gave the talk, a previous talk on this about domestic sheep, she's doing a master's on trying to clear Movi from domestic sheep with antibiotics. So, and I don't know, she's in her 2nd year, but her 1st year showed some success, but it wasn't, even with multiple treatments of antibiotics, we don't have a feasible treatment at the moment for either domestics or bighorn. So, I sympathize. I would like to not have to remove any sheep, or, I'd like to keep them all alive, but I don't think that that's possible.
Mm-hmm. Thank you.
One quick question. Of the 5 sheep that were removed from the Whiskey Basin herd, 3 of them had sinus tumors. Can you comment on the occurrence of sinus tumors and the ones you've removed? And also, can you inform the audience about the importance of sinus tumors in the continuous spread?
Yeah, so sinus tumors, you said you already talked about what they are and everything, so.
No, not yet. There were 3 out of 5 here that had sinus
that had
tumors.
the sinus tumors.
And did you have many in Hell's Canyon? And inform the audience of how that contributes to the continued exposure and transmission.
So we did not have any in the Hell's Canyon herds that we cleared, or we didn't detect any. We do have sinus tumors in the Lostine where we haven't been able to clear it. So, just keep that. I think we're still going to clear it from Lostine, but I think sinus tumors are an inflammation of the lining of the sinuses. The sinuses normally are very smooth, and there's bacteria don't flourish there. But when you have these tumors, it can trap bacteria, and then it can be very hard to get rid of them. And so that would be conducive to chronic carriage. And I think we still have a lot to learn about sinus tumors. There's various levels of sinus tumors, from mild to severe, and those might have different implications. But I do think that at least from what we've seen and what some Colorado has seen is that those animals do tend to be more likely to be shedding respiratory pathogens and including MOV. But there are animals with sinus tumors that do clear MOV, and there are some animals without sinus tumors that become chronic carriers. So it's maybe a contributing factor, but it's not, you know, it's not the only thing.
Steve, yesterday, we talked about a few things with Dr. Francis. Is there anything I'm missing that we want to make sure that we touched on today? She mentioned selenium in her presentation. I'm just thinking, Dr. Francis, about what are the locals in Du Bois asking? And while we have you here, just want to make sure that we extract as much as we possibly can.
Well, I really want to help the sheep in Du Bois, and particularly the Whiskey Mountain sheep, because, you know, they helped us. That's why we have sheep in our redbird herd. That's our, you know, one of our premier bighorn sheep herds. So yeah, I would really be happy to answer any other questions that people have now or later on. Yeah, I really want to see this work in Red Creek and beyond.
I agree. One more question. This is from Juanita. It's the same Juanita I know. This is Juanita Smith out of the Wyoming chapter of Wild Sheep. So Juanita, feel free to, oh, it's actually Kurt. Hi, Kurt.
Hello, Sarah. Yeah, it's my
Thanks for joining us
my
today.
wife's Zoom account. So yeah, there's no Juanita underneath these gray beards. No. My question is, with the test and remove, you test the first year, of course, you're collaring and tagging so you can identify all those sheep again. What's the time frame from the time you capture the second? How long do you have to hold these sheep, or do you have a process that processes this test swiftly to see that they're carrying again?
So you don't have to so that you can just hold them and not recapture them. Is that what you're asking?
Well, in our large wild populations, that's probably, that's not going to be feasible. But if you capture one market, you capture it again the next year, how long does it take from a sample to a positive test determination?
Yeah, so right now, the Washington Animal Disease and Diagnostic Lab, or WADL, they have a 24-hour turnaround. So you could put it in a trailer, like a horse trailer, and which we do, like when we translocate sheep, they do fine there, and just hold it overnight. And you should have a result. If you can get the sample up there, by the next morning, they can probably get you a result by the end of the next day. And then you could release it, if it was negative, you could release it the following morning, something like that. So it's feasible to do that if you're in the right situation. If you have a trailer. And we've done it also where we don't have any roads, where we also have sheep transport boxes, and we've put them in those, and you can helicopter them out. You can be kind of creative to do that. We are also working on an animal side test that might take an hour or less, but we don't have anything yet that we feel really confident about making decisions like that on.
And that's a promising thought, that you could get a test that would be, not instantaneous, but very short term. So you're not going to have to hold these animals for long periods of time.
It would be really helpful, like especially if you're going to have animals in wilderness or someplace where you're right, you're not going to get to go capture them again. So, yeah.
All right, thank you.
Thanks, Kurt. One thing I'd like to add is this week's paper in Du Bois, Vic Augustine did a 2-page article on test and remove out in the Red Canyons. And one thing that he emphasizes, echoing Daryl Lutz's presentation on our annual meeting, is that this is a strategy of last resort. And we're not being cavalier about this. There's sensitivities, and it's sad, but to save the herd, to save the sheep. This is the next viable approach forward. And I'm really glad to have Dr. Francis here today to show us and tell us how it's worked in other areas. So we will make that article available to our members, either on Facebook. We'll get it out there so you can read Vic's perspective. But he really shows the human side of this when we're thinking about management. And I think that's an important part in the whole approach.
Yeah, I'll just add an opinion that, you know, when we started it, you know, it is a difficult decision to make sometimes, but when, you know, you saw those pictures of dead lambs, that was only a fraction of what we were seeing. And that kind of makes it easier to just try something, because that was happening every year. So I guess you have to put it into context. Just what Sarah said is what's the situation you're in? What are the trade-offs?
Well, we are at noon. I want to thank first and foremost Dr. Francis for coming out and spending this time with us. We're very excited to get this program on recording and make it available. Visit our website. There's a front page will take you to where we hold our recordings. The next up is on May 16th, Bruce S. Thompson tracking. So again, you can visit our website to see more details about that program. And just one more round of applause for this presentation. We're really excited to host this webinar series. We welcome questions, we welcome suggestions for future webinars, so that we are living towards our mission of being an education and outreach resource for wild sheep and wildlands. So thank you to everybody who showed up this afternoon, and I hope you all have a wonderful Saturday. All right.